Hello, fellow Scratchers! Do you want to code an online cloud game in Scratch? Perhaps even a massive multiplayer game with anything from 2 to over 100 players? Well then you've come to the right place. Because I can show you how we can upgrade almost any Scratch game to be a multiplayer game. Conceptually, we just need each player to share their player's position and costume details, because if we know where they are, then we can display them in our game too. In these tutorials, we'll learn step by step how to create this fully backpackable cloud engine that can be easily dropped into all your games. And yes, we'll cover cloud variables, data encoding, buffering for smooth movement, and of course, how players join and leave our games. So buckle up, smash that like button, and let our crazy fun journey into multiplayer coding begin. Guys, let's get scratching. But hold on. Are you a new Scratcher? You can check right here on your profile page. Sadly, until you're invited to full Scratcher status, you won't be able to play or create cloud games. But before you start to panic, all you need to do is share a few projects, love and comment on my other people's projects, and very soon you'll find an invite appears right here on your profile page. Okay, great. Let's start a new project. In this first episode, we are going to cover the basics of cloud variables, how they work, and perhaps more importantly, how they don't work. So if we create a new variable, cloud1, you'll notice we have the option to create this as a cloud variable stored on the server. And this is where the magic happens. By storing a value on the cloud server, every Scratcher looking at your project will share the same value. When we first create one of these, we get a warning. It reads, "Please note, cloud variables only support numbers, not letters or symbols." And so we meet our first limitation. Cloud variable rule number 1. You can't write letters and symbols to a cloud variable. And that is a real pain. Our lives would be so much easier if we could stuff text into these things. But that would be open to abuse. So we are where we are. Numbers only. Okay, shall we see the cloud variable in action? When this sprite clicked, change the cloud variable by 1. A simple enough test. Just click the cat, and we see cloud1 increases as expected. But to test this properly, we need to see the value changing on another Scratcher screen, right? That's the whole point. Well, you could get the help of another Scratcher to load up your project, but for simplicity, we can actually test this all ourselves without even sharing the project, which is great news because who wants to share an unfinished game? Make sure the project is saved, and then switch to the project page, and move that web browser to one side of the screen. Next, we need to duplicate the current tab. I did that by right-clicking, but you otherwise could just create a tab and find your project in the normal way. It doesn't really matter. And then I pull the new tab away from this browser window and drop it to the right. Okay, this is looking good, but both projects agree that cloud1 has a value of 3. Now, when I click on the cat again, the value changes to 4, but this time also changes to 4 in our second window too. Wonderful! This is what cloud variables do. They share their value with everyone else almost instantly, but not quite instantly. In fact, it takes around 1/10 of a second for the value to transfer from window 1 to window 2, a lag of around 100 milliseconds. And yes, you can click either cat, and the update works in both directions. Now, there's only so much fun you can have clicking cats. How can we go from this to this? Well, let's start small. Say we have the Scratch cat follow the mouse pointer, and try to get the second window to mirror these movements. Now that would be cool. When flag clicked, loop forever, go to mouse pointer. We know cloud variables can share a single number with another Scratch project, and a sprite's position is made up of 2 numbers, given by an X position and a Y position reporter block. So why not create a second cloud variable, cloud2, and don't forget to check that cloud variable option. And now we can set cloud1 to this sprite's X position, and the cloud2 to the Y position. Nice! Running the project clearly shows both cloud1 and cloud2 updating. Okay, since these values will be shared with window 2, we just need a second script to reposition the sprite using these shared values. When 2 key pressed, this allows us to indicate which window is number 2. Stop other scripts in Sprite. This ensures Window 2 won't be running these left-hand scripts. Instead, we loop forever, setting the X position to the value shared with us in Cloud 1. And the same for Y position, but with Cloud 2. Nice! We have to test this! Once again, ensuring the project is saved, then see Project Page and duplicate the tab. If, however, you left the window open, which often I do, then make sure to reload that page, otherwise the project will be out of date and may lead to confusion if things don't work as expected. Okay, here we go. Both projects are running, but I haven't pressed the number 2 key yet. To proceed, first click into the right-hand window to ensure it has focus, and then press the 2 key. Boom! My cat just flew over to the right. Why did it do this? Well, it's because the cat on my left screen is positioned to the right, and this window is now copying its movements to here. Now, let's bring my mouse back to the left. And look! The X and Y positions of the first sprite are shared, allowing us to reposition the second sprite to match the first one. This is basically how multiplayer games are coded in Scratch. But wait, do you notice something a bit off? The right-hand window seems to be mimicking the movements of the left window, that's great, but it's far from smooth. Houston, we have a problem. Upon closer inspection, you'll see that the movement occurs in steps, only horizontal, left and right, or vertical, up and down. It's quite peculiar, isn't it? Well, I did mention that cloud variables have their limitations, and we're witnessing some of them right before our eyes. The first limitation is this. Cloud variable rule number 2. Scratch waits 1/10 of a second between sending cloud updates. In other words, no matter how quickly you update cloud variables, Scratch will only send them at a maximum rate of 10 per second. Unfortunately, this rule also applies when we set 2 cloud variables together. In our case, the X and Y positions, resulting in one change being sent before the other. And thus the sprite moves horizontally, then vertically, instead of a smooth diagonal line. There is no way around this restriction, so the only way to share our X and Y values at once is to combine them and send them using a single cloud variable instead. Well, how about we just join these 2 values together? For example, an X value of 176 joined with a Y value of 40 would come out as 17640. Well, that worked, but now we face the challenge of not being able to distinguish where one number ends and the next one starts. The problem is, we can't insert a separator character because of cloud rule number 1, which states that you cannot store letters and symbols in a cloud variable. So, here is an idea. Let's record the length of the first number, 3, before the number itself, and we'll do the same for the second number, 2. Then we can join all the information together to give our encoded string value. Has that helped us? Yes, because to extract the numbers back out again, we simply look at the first digit, which is a 3, then we read out the next 3 digits, which gives us 176. That is our X value. The following digit is a 2, and then we read the next 2 digits and we obtain 40 as our Y value. Clever stuff! Let's code this up. Create a new variable named encoded string for this sprite only, and make sure to set it to an empty value. Now we'll create a custom block to let us add individual numbers to this encoded string. Name it write number, with a number input of val, short for value, and another label of to encoded string. Write number val to encoded string. Perfect. Make sure to run without screen refresh so it runs nice and fast. So after clearing the encoded string variable, let's try writing the number 1 to the encoded string. Yes, this will want to be the X position of the sprite going forward, but always start off simple. Now to code up that custom block. Create another variable, also called val, for this sprite only, and set val to the input val. Clicking the script above will set val to 1, as expected. Now the reason we're using another variable for val is to safeguard against fractional values, like say 100.5. This would really mess up our encoding, so we'll pop in a rounding operator to remove the issue before it occurs. Great. So then, we simply set encoded string to the join to itself, encoded string, and okay, two more things. So another join, the length of the variable val, not the pink one, but the orange one we just rounded, and then the value itself. A length of 1 and the number 1 should come out as 1111. Pop that on the end of the encoded string and this custom block is done. We can test it by clicking the above script again, and encoded string is indeed 11. Well, how about we write a second number 2? Click. Not a problem, one digit, the number 2. And a longer number, 345. Click. We see 3 digits followed correctly by 345. Great. Now, the next step is to retrieve these numbers from the encoded string, which is known as decoding. The key to this is to keep track of our current position in the encoded string as we start from left and progress across. To accomplish this, we'll introduce a new variable named encoded index, IDX for short, specific to this sprite. This variable will serve as our tracker. We'll initialize the encoded index variable to 1, indicating the starting position as the first digit of the encoded string. Next, let's create a custom block responsible for decoding each number. We'll name it val equals read number from encoded string. Apologies for the lengthy name, but it accurately describes the block's purpose. Remember to set the block to run without screen refresh for optimal performance. To facilitate testing, let's plug in the code right away. Assuming the encoded string variable begins 1112, for the initial read, we aim to retrieve the number 1 for the length, and another 1 for the value itself. First, let's ensure that the val variable is empty at the start. Next, we'll retrieve the value of the current letter in the encoded string, which will be 1 as expected. Just remember the current position is given by the encoded index variable. Right, so we can agree that this returns the number of digits that we need to read in to get the full value. So how about we use a repeat block for that exact number? Currently, we will repeat only once, but for longer numbers it will repeat around as many times as there are digits. We need the next digit, so let's immediately change encoded index by 1. And now, letter encoded index of encoded string will give us the next digit in the encoded string. We'll want to append this digit to the val variable by setting val to the join of val and this next digit. This repeat loop will then do its job, looping around adding digits to val. The only thing left to do is to ensure that we increment encoded index by 1 more at the end. So we are positioned to read the next number from the encoded string. Well, this is exciting! We can now test if we can correctly decode these numbers. Click this script and confirm that we obtained the first value, which is 1. Nice! There it is in the val variable. To get the next one, we simply need to run a read number block on its own. Click. Splendid! There's our number 2. And with one more click, we get 3, 4, 5. It perfectly matches the order and value of our encoded numbers. Great! With this, we can encode and retrieve our numbers. However, we mustn't forget that the screen positions of sprites can often go negative. If we try to encode a negative number like -10, then, oh dear, 3-10, that will definitely fail cloud rule number 1, as it's not a valid number. Somehow we need to encode negative numbers without using the negative symbol. Well, since no numbers will begin with a 0, and the negative symbol always appears at the start of a number, how about we simply replace the negative symbol with a 0 instead? So -10 will become 010. And we can identify it as a negative number because it starts with a 0. Haha! Well, let's code that up into our right number script. We first check for negative numbers. If the value val is less than 0, we'll use a set val block, joining a 0 digit on the left And we need to be careful to remove that negative sign from val. So we'll use the absolute value, abs, of val. Simple enough. Click the test script and see how our -10 now becomes 0, 1, 0. Of course, preceded by a 3, as it is 3 digits long, including that new 0. And that's cool, because it passes the cloud rule test. The same goes for -20. No negatives in sight. Next up then, we need to decode these values. Currently, if we read out the first encoded negative number, we get back 0, 10 in the variable val. It should have been -10. So all we need to do is watch for the leading 0 and then convert that number to a negative, resulting in -10. We'll add this script to the bottom of the define read number script. If the first letter, letter 1, of val is equal to 0, then we set val to be negative val, or in other words, subtract val from 0. Let's quickly test it. And yes, now we are getting back -10 just as we hoped. Click on the next read number block and out pops -20. This is great news. It means we now have fully functioning encoding and decoding scripts. Wow, finally we can put these to good use. Remember why we are doing this? Oh yes, our Cloud player was moving in steps because Cloud Rule 2 says we shouldn't update more than one Cloud variable at a time. Well, no problem now. We can encode both the X and Y positions into a single value. So back to our original game loop, we begin by setting the encoded string variable to empty. And then using our write custom block to encode first the X position and then the Y position of this sprite. After that, all we need to do is set Cloud1 to the encoded string. Super! That sorts out player 1. And the Cloud variable will make its way over to player 2's computer, which is running this script. All we need to do now is decode the values out of it. Begin by setting encoded string to the new value from the Cloud one. Then set encoded index to 1 to start decoding from the very first letter. Now we use our read custom block to get the first value out of the encoded string. This is an X position, so immediately set the X position to val. Then we can do the same again, read a value, and this time set Y position to val. Excellent! Because that, my friends, is all there is to it. To test this out, make sure the project is saved and then get those two browser tabs side by side, remembering to reload the right-hand page if you kept it open all this time. Now, with both projects running, I'll click into the right window and press the 2 key. Gotta remember to do that. When my mouse is over the left-hand window, the cat in the right window follows my motions, but how much better is this? We can move the player diagonally and the Cloud player doesn't glitch sideways at all. Nope, no stepping to be seen. Also, the lag between my left movement and my right movement is surprisingly small. If you got this far, then you can be pretty chuffed with yourselves. It's super cool. But we are far from perfect yet. You will notice the movement on player 2's screen is more choppy than on the first screen. This is because Cloud rule number 2 also states that we can't update a Cloud variable faster than every 1/10 of a second. So, even though we are only updating one Cloud variable now, we are still updating it at a rate of 30 times a second. The rule is that Scratch will only send 10 changes per second max. So, 2 of every 3 animation frames we are sending are skipped. This is far from ideal, and is not the smooth gameplay action we might expect from a top-class network game. So, how do we fix this? In the next episode of this exciting series, we will learn how movement buffers and data streams can smooth out player motion, making our games look top-notch. But in the process, we'll also begin to expand our Cloud engine to take advantage of my latest massive multiplayer online techniques, as seen in my MMO Minecraft and my MMO platformer projects. These can easily handle vast numbers of players and are seriously a lot of fun. The great thing about these is that they also make joining and leaving a game way more robust than my previous Cloud engines and support testing on that single unshared project, a huge bonus for us Scratch developers. Well, I hope you enjoyed this video. If you did, then please smash that like button under the video. Did you click it? And if you don't want to miss the next exciting episode, and guys, it's going to be so cool, then make sure you subscribe to this channel, and that you've clicked that bell icon to be notified. Lastly, if you're interested in supporting this channel further, then you can join my channel membership. There are some cool perks and even the option to get access to the Scratch projects that go along with each episode. So cool! That just leaves me to say thank you for watching. I hope you have a great week ahead, and scratch on, guys!